So now what I'd like to do is, as always, preview your assignments for this week. So let's first of all start by taking a look at the lecture assignment. So in this case, we're given information that data were collected on the per pupil spending and the percent of the population with a bachelor's degree for each of the 50 states in our country. And the scatter plot is shown in the graph. All right. So the first question, does it look like there might be a linear trend to the data? So just can you sense that if you put your pencil across the dots that they would hover around your pencil line? For this data, I give you the R value. You're supposed to comment on the strength, direction, and trend of the association. So strength, weak or strong. Direction, or very strong, sort of strong. You know, we have a little chart to help us do that. Direction, is it positive or negative? And trend, the only trends that we're studying in our class are linear trends. So the trend will always be linear. So this, just decide, is it strong? Is it positive or negative? And the trend will be linear. I give you the R squared value, and it says, explain what this means to someone, and this is really important, who is not taking statistics. So a sentence that's not full of jargon, a sentence that's not full of, complicated terms, a very easy to understand sentence about what that R squared value tells you. In number 4, you're given the regression equation, and I ask you to use it to predict the percent of the population in a state with a bachelor's degree if you know their per pupil spending level is $15,000. So you have the equation, you know the per pupil spending is 15,000, you put it in the equation, and you use it to find the percent with a bachelor's degree. And finally, in number 5, it says, give an example of per pupil spending level for which it would be inappropriate to use the regression equation to predict the percentage with a bachelor's degree. Remember, it's inappropriate to extrapolate. So pick a value for per pupil spending that would be obvious extrapolation, obviously a value that's not in the scope of your data. Okay, so hopefully you're going to find that a quick and easy lecture assignment that will reinforce some of the important examples that we learned in class together. Okay, let's take a look at your other assignments for this week. So we're going to go next to your journal assignment. Look at that. There's only 3 more after this week. Exciting. Okay. So I give you a journal article from the Journal of Clinical Psychology to look up. First question, what type of study is this? Hint, it probably is correlational, but you decide based on, reading about the study. Okay. Part 2, question 2, it says, focusing on the results given in section 3.1, positive associations were found between which variables, and between which variables do they find negative associations? So remember, you're going to be able to do that by looking at the values for R. Values for R that are positive reflect positive associations. Values for R which are negative reflect negative associations. And again, confine your attention to that one section of the article. Number 3, the strongest association was found between which 2 variables, and how do you know it was the strongest? Remember, the strength of a correlation refers to how close your R value is to positive 1 or negative 1. So whichever R value is closest to either positive 1 or negative 1 is the strongest association. In number 4, it says the details of hierarchical regression analysis described in section 3.2 are beyond the scope of our class. However, we did discuss the concept of multiple regression. Just in case I forgot to do this at the beginning of class, multiple regression simply means looking at an association between more than 2 variables. Linear correlation and linear regression refers to the association between just 2 variables, like per pupil spending and bachelor's degrees. But what if we wanted to look at the association between more than 2 variables? For example, per pupil spending, percent unemployment in the state, for example, and percent bachelor's degrees. Maybe that's something we'd like to look at. Or maybe we would like to look at, per pupil spending in K-12 and then some kind of funding level for the public university system, and using those two variables to predict percent with bachelor's degrees. So multiple regression simply means looking at more than two variables at a time. So it simply asks you, what kinds of multiple regressions did the researchers look at? So what kinds of relationships between more than two variables? And then finally, which aspects of the article reflect diversity, equity, and inclusion? And again, try to make your answer more robust in that area, thinking really thoughtfully about those issues related to this article. Okay, and finally, let's take a look at your SPSS assignment, your lab assignment. Oh, look, only two more of those, and possibly one more that's optional. So in your lab assignment today, you're going to learn how to use the SPSS to find R, to find R squared, and to find the relate the equation of the regression line, the three things we talked about. So there's going to be some data that you'll upload to SPSS, and you're simply going to use this path. It's really easy. You go to Analyze, Regression, Linear. Analyze, Regression, Linear. You put mood change into the dependent box and forest bathing into the independent variable box. And then you click the statistics button and check the R squared box. So just simply follow the steps in order. Don't skip anything, and you're going to be fine. And what you're going to get is a summary table that's going to look exactly like the tables that we looked at in our notes together. Okay, and I'm hoping that I'll be able to make a video for you where I do that in SPSS for you. So those are your assignments for this week.